Exact equation. In this video, I will explain you the method of solving the ordinary differential equation that is exact in nature. Previously, I explained you some of the methods for solving the ordinary differential equation, or you can say like an elementary differential equation. That was the separable equation method and the homogeneous equation method. If your equation is separable, then you can go on to the separable equation method. If the degree of the given ordinary differential equation is homogeneous, then go on to the homogeneous differential equation method. That is explained separately into different videos. Now the third method I am going to discuss is solving the exact equation. For that purpose, you must know the definition of the exact equation. The definition of the exact equation is, if you are given differential equation, the given differential equation m of xy dx plus n of xy dy equals to 0 is called exact equation if and only if take the derivative, partial derivative of this m with respect to y, and it will become equals to the partial derivative of n with respect to x. That is, partial m over partial y equals partial n over partial x. The derivative of m with respect to y will equals to derivative of n with respect to x. If both the statements will become equal, then you can say like your given differential equation is exact in nature. For example, you are given with a differential equation, ordinary differential equation, that is dy by dx equals x square y plus 1 divided by 2 plus xy. Now you will rearrange your given differential equation into this format and then take out your m and take out your n. Find the partial derivatives with m with respect to y and n with respect to x. If both will become equal, then you will say like this is your exact equation. Then you will proceed to the specified method for solving the exact equation. Now how you can just rearrange it into this format, just make it straight line equation. Just cross multiply the terms. You will get here 2 plus xy dy equals x square y plus 1 dx. Now move it on your left side. You will get here negative time x square y plus 1 dx plus 2 plus xy dy equals to 0. Now this term is your m of xy and this term is your n of xy. So now you see that your equation is now in the format of this differential equation. Now you will figure out whether this is equal or not, and then you will move on to the specified method of solving the exact equation. Let's move on to the specified method of solving the exact equation. The given ordinary differential equation is 3x square y plus 2 dx plus x cube plus y dy. Now, if I compare this given differential equation with m of xy dx plus n of xy dy equals to 0, then I will get here m as 3x square y plus 2 and n as x cube plus y. Now, you have to find the partial derivative of m with respect to y. So, with respect to y, you have to take the derivative. Other things will be treated as constant. 3x square times 1 plus 0. So you will get here partial m over partial y equals 3x square. Now take the partial derivative of n with respect to x. You will get here partial n over partial x equal 3x square plus 0, because this is treated as a constant here now. You will get here partial n over partial x equals 3x square. Now you can observe that your partial m over partial y is equals to partial n over partial x. So the given equation is exact in nature. Now it is exact in nature, so you will just follow the method for finding the solution of this equation. And what is that method? You will just write your m function equals partial f over partial x and your n function as partial f over partial y. m will be equals to partial f over partial x and n will be equals to partial f over partial y always. Now, so what is your partial f over partial x? Partial f over partial x is equals to m. And what was your m? Your m was 3x square y plus 2. 3x square y plus 2. Now, you will get here partial f equals 3x square y plus 2 partial x. Now, integrate both sides with respect to x. Integrate both sides with respect to x. You will get here f, because this will be cancelled. You will get here f equal integration of this function with respect to x. You will get here 3x cube over 3 times y plus 2x plus. Now, the constant will be the function of y here. Because you are integrating it with respect to x, so your constant will be the function of y. So you got here f equals 3 will be cancelled with it. So you got here x cube y plus 2x plus h of y. Mark it as equation number 1. Now move on to this side. Your n is partial f over partial y. So partial f over partial y equals n. And what was our n? X cube plus y. So you got here partial f equal x cube plus y partial y. Integrate both sides with respect to y. You will get here f equal x cube y plus y square over 2 plus. Now your integration was with respect to y. So your constant will be with respect to x, g of x. So you will get here these two equations. The first is f equals x cube y plus 2x plus h of y. And the second equation is x cube y plus y square by 2 plus g of x. Now you will do what? From equation 1 and 2, you will write the solution. That is f of xy equals, the solution will be f of xy equals, you will write all the functions one by one here. Now you can see that don't repeat the same functions. X cube y is repeated. So you will write this function one time only. So your solution will be x cube y, this one you have written. Now plus 2x plus y square by 2. You have written all the functions. And in place of h of y and g of x, you will write here constant of integration c. So this is the solution for your exact equation. What you have to do in these questions? You have to do what? You have to just find your m, find your n. Then check whether it is exact or not. How you can check? If your partial m over partial y becomes equals to partial n over partial x, then it is exact. Then you will move on. How you will move on? You will write partial f over partial x is equals to m and partial f over partial y is equals to n. You will integrate this one with respect to x and find your f here. And constant of integration will be h of y here. And from here you will integrate it with respect to y. And you will get f equals this sum function plus g of x. Now you will write your combined answer for the solution as from these two. Write all the functions here. Don't repeat the functions which are same. And plus in place of g of x and h of y, you will write the constant of integration. So in this way you can solve your exact equation.